Greetings everyone, I am Srinivas Krishna from Knowledge Institute of Technology and my team ID is PNT 2022 TM ID 30308 and my team members are Mr. A. Nandhagopal Vignesh, Ms. S. Haripriya, Mr. L. Dhinakar. In the domain of Internet of Things, our use case is real-time river water quality monitoring and control system. The problem statement of this use case is when farmers use fertilizers and pesticides in their farmland, these substances gets washed out due to rains and get sedimented in the rivers and lakes. These changes causes the growth of algae over the surface of water. This is a natural phenomenon known as eutrophication. And after a time, when the algae die, it gets decomposed by the bacteria present in the water. This process takes up all the oxygen present in the water so that this directly affects the marine life. Not only the marine life, also the lives depend on the water bodies. So the proposed solution is, to overcome the problem, we propose a solution, a product which is a smart system to monitor the water quality real time. So this is a 24/7 monitoring system which provides the authorities all the information they need about the parameters of the water quality. Whenever there is an abnormal activity in the parameters of the water, it will alert the user, the administrator, with SMS notification system and also a in-UI application. The product gives the authorities both web application and a mobile application for their convenience. So this is an industry project where we provide them with all the necessary things and they could access the data whenever they want and they can have the option to control the motor placed in the river within. Okay. To overcome the problem, we propose a system which can monitor the water quality 24/7. So this is a real-time quality monitoring system which allows the authorities to monitor and control the water quality at any time they want. So the user is provided with both web application and a mobile application for their convenience and they are alerted when there is an abnormal activities. The alert is by means of two. The first alert is the system UI alert in the application itself. The second type of alert is using an SMS service. They can control the motor placed in the river by. The main task in this project is to generate data. So random function in Python is used to generate all the necessary parameters for the water quality monitoring. All the data is stored in the JSON format and transferred to the cloud for the further process. Once the Python code is executed, all the generated data are transferred to the cloud platform in the JSON format. This is the device I created in the IBM Watson IoT platform so that it receives all the data from the Python code. As we see here, all the data are receiving in real time. So these data are then transmitted to the Node-RED page. In the Node-RED page, I have created this node to receive all the data from the platform. As we receive data in the platform, we will also be receiving the data to the Node-RED page for the further process. So here we are at the important part of our product, the condition. As we separated our parameters into primary and secondary, each gets its own conditions. These conditions are written in JavaScript according to the datasheet mentioned. Once the parameter data gets in the abnormal condition, the further process will be carried out, which is the notification and stuffs which will be discussed in the further sprints. Here we are at the final part of our project, alerting user. So for alerting the user, we have two means of communication, the UI alert and SMS notification alert. For the UI alert, it is separated into two ways, the primary alert and the secondary alert. For the primary alert, it is set as pop-up notification as our primary condition is very important. So once we deploy the notification and as a Python code is running, when there is abnormal activity in the primary parameter, we will receive a pop-up notification, alert abnormal activities. So if I click this button, go to motor controls, the UI will automatically be shifted to the motor controls. So where I can turn on the motor and receive the command and turn off the motor and receive the command itself. So after a few time, I can also receive the continuous monitoring output and go back to the motor controls and turn on and turn off the motors. And for the secondary alert system, which is not quite important, we have used push notification. So if there is any abnormal activities in the secondary monitoring, there will be just a push notification which will be alerting the user there is abnormal activities, but it will not urge the user to turn on the motor or turn off the motor. So here we have the performance metrics, the non-functional test and also the end of test report. In future, this product still might be helpful to solve many issues related to river water monitoring. In spite of this reason, the product can even be upgraded and can be added more and more features to help people monitor water and to have a healthy lifestyle. There can be some upgrades made, like the water monitoring station could be made portable so that not only one part of water is monitored, all parts of motors are monitored and exact results have been transferred. The speed of the system can be improved by the use of 5G. The 5G can give us latency-free. There can be some upgrades made to the system so that this can be more helpful to the people. Upgrades like the monitoring station could be made portable so that not only one part of the water is monitored, and also we can use 5G service to reduce the latency of the service so we can have the accurate and on-time data as soon as possible. These are all the future scopes of this product. Thank you.